and set that equal to 0, then what do you
get E for y.
Yeah, you get that whole thing, right, equal to 0? Like you're just setting this whole thing equal to 0, right?
Can you set it to yeah, can you set it to something else?
Let me write it down.
Natural log of it?
I'm hearing natural log, which I'm sure you could do, but is it necessary? Just x is 0. Why not? Why am I not even going to worry about this?
Because x is 0, so it's
Negative 2x times the x equals 0, and that's 0, and 0 times whatever is 0.
Well, I agree x is 0 is a solution, but is it the only solution to this? I agree x is 0 is a solution, but is it the only one? So you need to ask yourself.
E to any power is a number.
That's right. E to anything can never be 0. Think about the graph of E, right? E is like this. It asymptotically approaches 0, but it never is 0. So this entire term right here, you could divide this out on both sides because you don't have to worry about dividing by 0 because this can never be 0. So you just clear it out completely. Right? Okay. Now, another way you could have done that is you could have, if you're not happy with that, is since these are being multiplied, you could set up two equations and then set the other one up. This one just gives you 0, which we knew already. But this one, if you wanted to bring the natural log in, you could. You do, natural log here, natural log here. Oh, you have a problem. Natural log of 0 is undefined, right? So you would automatically, you'd know there's issues, right? Okay. So we only have one solution from that. X is 0. Well, this is kind of boring too. What about this one? Fy equals 0. Same story, right?
no.
This can never be 0, right? So I need to set that to 0. 4 minus 2y equals 0, so y is 2. So the only way we're ever going to have anything happen here is if we are at the critical point 0, 2. Now, I skipped over the second partials. I said I'd wait on those because I realized that those are going to require some work. I mean, just the derivatives are a little bit more involved, right? When I take the derivative of this with respect to x again, I'm going to have to use some product rule. So let's do it. So the critical point wasn't that bad in this problem. The second derivatives, the second partials are going to be a little ugly. All right, I think I'll rewrite this. Rewrite this as negative 2x e to the 4y minus x squared minus y squared. That's the partial with respect to x. Now we're going to do partial with respect to x again. Partial with respect to x, again, would be product rule. Here's my product. I'm going to look at it right there. So derivative of the first part is just negative 2 e to the junk. I don't feel like writing that. Is that okay? E to the junk, and then plus the derivative of e to the junk, right? Which is e to the junk again. Are y'all all right with me being that lazy? Okay. Look, I had very good professors in my college career that used junk. They actually would write the word junk. So I'm doing it too. All right. All right. So e to the junk plus, okay, derivative of this is itself, but then we have what pop out of it? A negative 2x again, right? But what was the first piece? We have to bring that in because this is product rule. Another negative 2x. And now what I'm going to do is I'm going to factor. I'm going to factor out a negative 2, e to the junk, right, is in both of these. And what would that leave me if I factor that out?
1 plus
1 plus
negative. No, x squared.
1 plus x squared. Okay.
Well,
No, sorry, 2. this is a 2,
Yeah.
right? And I pulled out a negative. Sorry. Because this is positive. Yes, that's it right there. All right. And just to have it all here, e to the 4y minus x squared minus y squared, and then 1 minus 2x squared. There we go. That's our partial with respect to x, and then with respect to x again. Unfortunately, the partial with respect to y, and then y again is not the same thing, just different number. And we have a little bit of work we have to do with that. So get that one now. I'll do it right here. Partial with respect to y, then y. I'm going to do my product rule right here. All right? I'm going to do it right here. So I'm going to do derivative of this times this plus derivative of this times this. So derivative of that is itself, e to the junk, times derivative of what's up top with respect to y. 4 minus 2y. But then times 4 minus 2y again, and then plus. So that was my first part. Now, the derivative of the second one is just negative 2, and then times the first part, e to the junk. I'm just going to factor out an e to the junk. That's all I'm going to factor out. I could factor more, but I'm going to just do that. E to the 4y minus x squared minus y squared comes out. I'm left with these two, right? So I'm going to write as 4 minus 2y squared, but then over here I'm left with minus 2. Now we need another one. It's the partial with respect to x followed by y, which is this one right here, right? This one? No, sorry.
It's the first one.
This one, right? Which is this one. I'm going to do this one right here. I'm going to do that, but then with respect to y. And there's some good news here. There's no product rule necessary because negative 2x is a constant, right? So this is a constant sitting in front of a function. So my derivative with respect to y should be negative 2x, e to all that junk, right? But then times the derivative of what's up here with respect to y, 4 minus 2y. No product rule. Everyone understand why there's not? Okay. So negative 2x e to the 4y minus x squared minus y squared times 4 minus 2y. All right, now good thing is we're only going to calculate d at one point. It was what, 0, 2? 0, 2. So let's get d. I can get rid of this. I can get rid of this. So d at 0, 2 was fxx at 0, 2 times fyy at 0, 2 minus fxy at 0, 2, that thing squared. All right, let's plug in 0 for x and 2 for y. So if I plug in to xx, fxx, 0 for x, that's gone. I just get a 1 there. That's good. And then negative 2 e to the 8, gone, minus 4. 8 minus 4 is 4. So I should get negative 2 e to the 4th. Times fyy, that was this one. What is this going to be? E to the 4th. So e to the 4th times, now here, I'm plugging in 2 here, right? So that's 0, and then minus, so just negative 2. Hey, those are the same thing. Interesting, okay. Minus, now fxy 0, 2, which was this one. It's 0. That x really helps out, doesn't it? That 0 kills everything else off. So this is 0 squared. All right. When you multiply these two, this is a negative number, and this is a negative number. So when you multiply them, you get a positive. So this is greater than 0. Do you agree?
So it'll be 4e to the 8th.
I don't care. Yes, it would be 4e to the 8th. You add the exponents. But all I care about is that it's positive.
You need to check like fxx.
Yeah, now I need to check this. And that is what? Negative. So a negative, it's a local max. You have a local max, and it happens at 0, 2. Local max at 0, 2, and then e to the 4th. That's our final answer. I apologize that I have to cram all this information into this little spot, but that's the only way I can do this easily with a camera in the room. Did y'all follow it all? Yeah? Okay, let's take a look at this one. I want to see a picture of this. We've got this surface, right, that has this single local maximum at 0, 2. If I'm not mistaken, I think this is the pimple, I call it the pimple function. Yeah, it's just a little pimple. There it is. So that's what it is. It's just got this single little hill right there. You got a local max up there at 0, 2, e to the 4th. Now we're starting to get into some harder stuff here. How are we doing on time? 12, good. Let's try this one. Again, I'm going to start by just doing the first partials. Normally, I will do all the partials if it's an easy function to do partials on. Now this one I'm not saying is hard, but let me first work on getting my critical points. So my partial with respect to x, I'm going to suggest that you look at this function, f of x, y, as being x squared plus y squared plus x to the negative 2, y to the negative 2. That's the way I suggest you look at that. Bring both those factors in the bottom up. It's easier to do differentiation on this. So my partial with respect to x will be 2x minus 2x, hold on, negative 3 y to the negative 2. Okay, so derivative of x squared is 2x, derivative of y squared is 0 with respect to x. Here, this y to the negative 2 is a constant, so derivative of x to negative 2 drops down. Subtract 1 from negative 2, you get negative 3. But you still have the constant.
Yeah.
Okay, that's our partial with respect to x. Partial with respect to y is going to look fairly similar, isn't it? I mean, 2y minus 2x to the negative 2, y to the negative 3. So the only difference is that the negative 2 pops out from the y. Subtract. I've got to set those equal to 0. Let's do that now. Get rid of this. Partial with respect to x equal to 0. 2x minus, how about I do this? 2 over x cubed y squared equals 0. I'm going to go back to the fractional notation instead of negative exponents. And then I need partial with respect to y equal to 0. So 2y minus 2 over x squared y cubed equals 0. Any suggestions? X and y both cannot be equal to 0. I agree with that, but that doesn't make it a critical number because 0, 0 is not in the domain of the original function. You see the original function has something going on? Everyone agree? X cannot be 0 and y cannot be 0, else the function is not defined. You want to set them equal to each other? Okay, I'm up for that. Sounds fun? 2x minus 2 over x cubed y squared equals 2y minus 2 over x squared y cubed. By the way, you can't solve this for x and then plug it in over here, because if you try and isolate this x, you still have x here. So it's not as clean.
Not even if you multiply the x on both sides.
If you multiply what?
The x on both sides. Like if you multiply x cubed on both sides.
If you could clear the fractions and do something, yes. I'm just saying you can't just move this whole thing over to the other side and just replace that over here, because it won't. You'll still have x's, that's all. You can clear it though. Yeah. Which is really probably what you're about to do on this one anyway. Right? Get a common, or you can look at it. If I were doing this because I have an equation, I would just multiply both sides by the LCD, by the least common denominator, which would be x
X to the 6, y to the 6.
x. What's our least common denominator?
6.
X to the third, y to the third. Just think, what would you need to clear out these so you don't have fraction? You would need an x cubed and a y squared, right? But over here, to clear these out, you need an x squared and a y cubed. So if you do x cubed, y cubed, it'll clear everything. So I'm going to multiply the left side by x cubed, y cubed, the right side by x cubed, y cubed. Now, we have to be really careful about something here. It's subtle, but it's important. When you multiply both sides of an equation by something, you're totally allowed to do that, aren't you? You can always do the same thing on both sides, but you can never multiply both sides of an equation by 0. So when I do this step right here, I need to guarantee you that I'm never going to be multiplying by 0. So technically, I need to say that x can't be 0 and y can't be 0 for me to make this move. It's okay, though, because x equals 0 and y equals 0 is not even in the domain of the original function. But it's just something to pay attention to, that later, especially in 11.8, we're going to run into this. You're going to have to pay a lot of attention into how, what you're limiting yourself to. You'll see. Let's go ahead and multiply through. See if this helps us at all. Here, let's see, we would get 2x to the 4th y cubed minus 2y, and then equals 2x cubed y to the 4th minus 2x. So that's distributing here and here. Now what? Now can you do what? Set them each to 0? You can't set them each to 0. Oh, set the whole thing equal to 0? Like bring everything to one side? You can do that. You want to do that? Is that what you're... Okay, let's try it. So bring everything over to the left side. I'm going to do that. And I'm also going to try and do it in a way that hopefully makes a little bit of sense, that I would kind of order them this way. And does it make sense to you that I bring all the ugly stuff up front, leave the cleaner stuff in the back? Factor out what? From where? You cannot factor anything out of all of them, but by grouping. We can do grouping here. We have 4 terms, don't we?
Yeah.
We can try grouping. How about can I kill the 2?
Yeah.
Can I just kill the 2? I'm going to divide everything, both sides, by 2. And that makes it that instead. It's just a little easier to work with. All right, at this point, I'm going to factor by grouping. So I'm going to hope that this works. I'm going to just split it right here and take a look at the first two terms. What's a GCF out of the first two terms? X cubed, y cubed, right? I can pull that. X cubed, y cubed. What would be left if I did that? X minus y. Now, I need to be able to get the same thing here. So I need to pull out a what? You don't need a look, this is x minus y, isn't it? So I just need to pull out a positive one. But you need to pull something out. You can't just leave it without. Okay, so this is going to be negative y plus x, right? I'm going to write it the other way. Same thing. Equals 0. And that was very good that that worked, because now I can pull the x minus y out. And I have x minus y times x cubed y cubed plus 1 equals 0. Now set each one equal to 0.
X is going to be equal to y.
X must be equal to y is one thing. And the other one is that x cubed y cubed plus 1 must equal 0.
If x is equal to y, then you can just have that be x to the 6 plus 1 equals
Where are you talking? What? Huh? What?
He's saying substitute x for y since x is equal to y.
Yeah, so in order for these things to be true, I need x to be equal to y, right? Or I need this to be true. So let's deal with this one first. If I do this one, then I can go back to either one of these, right? And just replace the x with y. Or replace the y with x. It's up to you. It's up to you. So why don't we do this? I'll do it in different colors so you realize I'm actually using this substitution. I'm going to bring this back in here. Let me go back up to fx x partial of f with respect to x and rewrite it. It'll be 2x minus 2x to the what? Negative. Yes, but I'm replacing the y with x.
Oh, it's -5.
Negative 5. Okay, so I'm replacing this y with x. So it's now x to negative 3, x to negative 2. That's x to negative 5. So I have that, right? That's my original equation. Now I need to set that to 0. So take that, set that to 0. And that would be 2x minus 2 over x to the 5th equals 0. Multiply both sides by x to the 5th. Is that all right with you? Multiply this by x to the 5th, this by x to the 5th, this by x to the 5th. You get 2x to the 6th minus 2 equals 0. Move the 2 over, divide. You get x to the 6th is equal to 1. So x is equal to plus or minus 1. How many critical points did I just find? Found 2. What are they? So I'm going to list out my critical points here. I have 1, 1, 1. And then negative 1, negative 1. Look, we're using the condition that x has to be y, right?
Yeah.
In order for x to be equal to y, this should be true. Now, let's double check it. Would this have worked in this one? Like, if we would have replaced this with y, that would have given us the same solution. So we're good. All right, that took care of that, though. We still have this to look at. This might get us some more critical points.
Because you an imaginary number.
How do you figure?
Because if you
Remember, this is no longer, we're not even looking at that anymore, right?
Yeah.
We're just looking at that now.
Positive 1 to the 6th.
You do the cube root of the negative number.
Okay, is this true that if I'm using that one, that this now looks like x cubed y cubed equals negative 1, right? So I can say x cubed equals negative y to the negative 3. So I just divided both sides by y cubed. If you don't like that, then x cubed is equal to negative 1 over y cubed, right? You could say that also. Do we agree with that? Okay, so that means I can go and I can replace my x with, do you want to take the cube root now? I'll take the cube root. Let's take the cube root. X would be the cube root of negative 1 over y cubed, which would be? Negative 1 over y. So I can replace x with negative 1 over y. Yeah?
So when x is 1, y negative.
I'm going to go to this equation because it has a bunch of y's in it. So I'm going to replace that x right there with that. So taking this one, I have 2y minus 2. Now what is x?
Y
It's this, right? But I'm going to raise it to negative 2. So negative 1 over y to the negative 2, and then y to the negative 3. And aren't I going to set that equal to 0? I am going to set that to 0? What the heck is that?
would be 2y plus 2.
So this is 2y minus 2. What's this? What is this? Negative exponent on a fraction means flip the fraction over, right? And then squaring, you're going to square top and bottom. But wouldn't that just be y squared? And isn't this really like a y cubed on the bottom? That's just going to be 2 over y, isn't it? This right here, put together, should turn into 1 over y. However you want to do the algebra on that, that should become 1 over y. This is just properties of exponents, right? Okay. So this should be, I'm going to go 2 over y equals 0. And I'll clear fractions. I'll multiply both sides by y. Y. So you get 2y squared minus 2 equals 0. Y squared equals 1. So y equals plus or minus 1. And I believe we're going to get the same exact things, or are we not?
Does that mean that it can be 1 negative 1?
Yeah, so that's what I want. Does this mean that I just got the same two solutions, or are there two other solutions here?
There's 2 of these.
Because when we're looking at, x cubed, y cubed equals negative 1, basically saying that if 1 is x and y is 1, both are positive 1, it's basically 1 to the 6th, and that's equal to negative 1, and that's not true. So one of them has to be negative. And the other
Hold on. What you're saying, I don't disagree with you, but don't we have this equation at some point? This was our relationship between x and y. So if I replace y with 1, right? If I use the 1 here, if y is 1, then what's x? Negative 1, right? If y is negative 1, then what's x? Positive 1. So they are not the same points, are they? Okay, we have 4 critical points. Now I'm not going to calculate d on these, all right? You can go calculate d. You got to get more derivatives though, okay? Right, you got to get partial with respect to x twice, partial with respect to y twice, partial with respect to x then y. Plug in. See, I told you it would get a little more interesting. It's algebra, but it's interesting algebra. Yeah, it's 12, that's why I'm stopping. That's why I'm not computing anymore. 12:30? I was going to just end class early.
That's like half the exam right there.
Well, this is why 11.8's not on the exam. Because 11.8, I give you one problem that could take you probably the whole class.
A problem like this, would it be a little bit more conceptual, or is it going to be basically just this? Just with maybe complicated algebra.
You mean on the test? Oh, I'll talk about the test. Here's the actual surface we were just looking at. Remember we said x and y couldn't be 0? You had asymptotes there. So it's this weird like origami thing, kind of, not really. It's not connected down the center there. You've got these asymptotes, right? Like that. But you've got these four, these all turn out to be local minimums there at the bottom. See them? Okay, so we found those lowest points there. I wonder what the next one is. This one has...
With that,
This-
that very point at 0, 0, 0, we find that, but we wouldn't find all the saddles.
Oh yeah, you'd find them. If you went through and did all your partials and everything, yeah, you'd find all 5 of these points. It looks like there are 4 saddles and 1 local max.
But since that local max is there, if that local max in the center went all the way straight up and made all the saddles very up, and
If this went straight up,
yeah, like infinity, like the wall. You know what I mean? Like if it just went on forever.
I think you'd still have a saddle. These would still be saddles because it would still be turning up. There's that one we didn't get a chance to do. This one, is this the one? This is one I offer as a bonus. Okay? This is a bonus one. Huh? Yeah, you can turn this in on the day of the test. Now, don't go wasting like 4 hours of your life doing this instead of studying. But this one, I mean, you can already see where what the answers are by just looking at this. But it's worth going through, and there's something very interesting happening that's not listed here. So I'm curious to see if any student will figure out what I'm talking about. And we'll see. I haven't had anyone ever get it before, so we'll see if anyone gets it. All right, and then that's when we move into the second part of this section, which is where we have to now bound things. And I told you, remember what I said? When we start bounding our functions, it gets more complicated. In Cal 1, it's the other way around. When it's bounded, it's just critical numbers, plug in the endpoints, plug in the critical numbers, done. This is going to turn out to be crazier. Oh, I'm sorry. Okay. All right, the test. Y'all ready? I'm going to just talk to you about it. I have not made the test. But I have one from a previous semester here, and I was looking at it. Just to give you an idea, I think every single problem was a homework problem. Exactly. I'm not telling you yours will be, but I was testing to see how they would do if I gave them problems directly from the homework. And that way, if they failed it, I would be like, these were homework problems. Exactly, right? And there's no excuse if you can't pass that test. So that's what I gave them. There were 42 problems. No, I'm just kidding. There were 14 problems. They had the entire class, an hour, 40 minutes. Find this, again, I'm not saying this is what you're going to have, but it gives you an idea of what I asked. Find center and radius of a sphere. Finding the vertical and horizontal components of a vector. This is way early stuff. Finding one of the angles of a triangle. If I gave 3 points of a triangle to find one of the angles. Find the area of a triangle, given 3 points. Find the equation of a line through a point which is orthogonal to a plane. Find the equation of a plane, given 3 points. Find the vector equation of a line that is tangent to a space curve So I give you the curve. You have to find the equation of the line that is tangent to that curve at a specific point. There was a take-home test problem like that one, I believe. But where you had to find the intersection of a cylinder and a plane and then find, it's that, but I give you the curve, I give you the point, you just have to know what to do with it. Find the length of a curve. So I give you a vector curve, like a vector function, and you find the length of a curve. I give an acceleration function, and then I give some information about the velocity and I ask you for the velocity function. So that's integration. Show a limit does not exist. So a function of two variables, show a limit does not exist. So that's where you have to try different paths until you get two different answers. Find the extreme, find the derivative of a function in a specific direction at a specific point. That's directional derivative. That has to be a unit vector, remember that, right? And then the last two, find the extreme values in the saddle points of some function. I tell them, make sure your answer is an ordered triple, so the x, y, and z coordinates. And then number 14 is a problem from the second part of this that we didn't cover, so yeah, that won't be on there. That's what I've tested on before. I mean, so you can see those problems are all very much what the problems were like out of the book. There's nothing crazy from somewhere else. So I would say if you want to prepare, and I know me saying study your homework is very vague, but I mean, that's what you need to study. I mean, if you've done all your homework, which you're supposed to be doing, then you just go back and review it. Look through it.
What section is like 10?
That covers everything.
Yeah, literally.
That covers pretty much everything.
Which homework do we do for this section?
For this section, good question. All right, 3 through 13 odd. For this section, 11.7. Let me just double check that. 3 through 13. Yep, 3 through 13 odd. There are more, 23 through 27 odd, and then number 37, but that's from the second part of the section, which we haven't covered. And that's it. I hope you all have a great day. Anybody need to sign in? Here you go.